The Black Death in the 1300s killed 50 million people. That was half the population of Europe at the time. It was spread by person-to-person contact where people lived in very close quarters. So why did some people get sick while others did not? Dr. Donald Vinh is an infectious diseases specialist at the MUHC. Hi, Don.
Hi, Mitsumi.
So the Black Death, or the bubonic plague, it was one of the worst pandemics we know of on record.
Yeah, so the plague is an infectious disease caused by the bacterium called Yersinia pestis. And it can cause three forms of disease: pneumonic plague, which infects the lungs; septicemic plague, which spreads through the bloodstream; and bubonic plague, which causes swollen lymph nodes called buboes. Now, plague, as you mentioned, it sparked several pandemics, including the Black Death, and that likely spread through human fleas and lice and killed up to half of Europe's population. But the other half survived, and that's where things get interesting. Hygiene probably helped bring outbreaks under control, but genetics may have too. Some survivors might have carried protective genetic mutations that helped them resist infections. And over generations, those genes became more common, possibly reducing the impact of future outbreaks. But of course, there's a trade-off. Genes that aggressively protect against infection can sometimes increase the risk for other conditions like autoimmune diseases later on. And it's the same kind of evolutionary balance that we see with sickle cell anemia, where carrying one copy of the mutation protects against malaria, but two copies causes the sickle cell disease.
Now, did we see the same kind of thing in the COVID pandemic as well? I mean, there were people who were never vaccinated, they were not isolating, and they still didn't get sick?
Yeah, so that's a great example. During the COVID pandemic, as we know, only a proportion of people who got infected developed life-threatening pneumonia. And it turns out there's an immunological reason for that. Elderly males had this surprising rogue autoantibodies that neutralized a branch of their own immune response that was important for fighting off certain viruses, particularly COVID. On the other hand, younger adults and children sometimes had genetic mutations in that same pathway, and that led them to develop the severe COVID disease. And I was fortunate enough to be, the only Canadian involved in those international studies. But that idea was actually, that plays out for other infections. We know, for example, within a household that's affected by viral gastro due to norovirus, some family members do not get sick. And it's because they carry genetic mutations that protect them from infection. So understanding this genetic susceptibility or resistance to infectious diseases, that's what I study in my clinic and in my lab.
But we throw the word immunity around a lot. Is this what we're talking about here? What does it mean to have good immunity?
So the immune system is the body's army to fight off infections. And like every army, it's made up of different soldiers, and each soldier has a specific role. You can imagine that if many soldiers are not working properly, we can become sick to many different kinds of infections, like viruses and bacteria and fungi and parasites. But if you only have one soldier that's not working properly, and that the others cannot compensate for it, then you can be susceptible to only discrete infections, say something like only some viruses. So when we talk about good immunity, what we're really talking about is how well equipped our body's army is to fight when infection strikes. And we now know that our genes are a key component of what makes that possible.
But we hear, Don, about all kinds of, supplements and things that we should eat and whatnot that promise us that we can build our immunity. I mean, is that true? I mean, when it comes to fighting off disease, how much of it is in our control and what is not?
Yeah, so that's a great question. The immune system is incredibly complex. It has many layers and branches, and it's built with some redundancy so that if one part falters, others can step in. That's what has kept humans alive as a species for years, right? And it's also what we can capitalize on using science to strengthen our immunity. The best example of that is vaccination. Vaccination safely trains our immune system to recognize a germ before we ever see it. So when the real infection comes along, we're already prepared to fight it off. On the other hand, in rare cases when the immune system is severely damaged, we can replace it entirely with a bone marrow transplant, although obviously there's some risks with that. Most over-the-counter products that claim to boost immunity, it sounds appealing, but there's no real science behind them. The real next frontier is what we call precision medicine, pinpointing exactly which soldier in the immune army is missing or weak, and then using targeted therapies to boost that specific function safely and effectively.
Okay. Thank you very much for this, Don. Always interesting. Thank you.
Thank you, Mitsumi.